Welcome to the third lecture. So this is the third lecture and we'll be studying about the two types of reactions, that is combination reaction and decomposition reaction. Before this, let us just revise what we had done in our previous lectures. We did study about the chemical reactions between zinc and acid, between lead nitrate and potassium iodide, and we saw the color changes, we saw the exothermic reaction between zinc and acid, also the evolution of gas was there, right? So we studied generally how are we going to see whether a chemical reaction is happening or not. There were some clues by seeing which we were able to identify whether a chemical reaction is going on or not. Next, what we did was the balancing of chemical equations. Okay, so now this is the third lecture. We'll be studying now the types of chemical reactions, that is combination reaction and decomposition reaction. Okay, before going into that, I just want to show you with the help of this example that what exactly is happening in a chemical reaction. During a chemical reaction, the atoms of one element, they are not changing into that of the another element, nor they are disappearing from the mixture, or they are appearing from elsewhere. But what is happening is that in a chemical reaction, the breaking and the making of bond between the atoms is happening. What I mean to say is that the bond between hydrogen and hydrogen, right, and also over here next hydrogen and hydrogen, that is going to break, right? The old bonds are going to break and they are combining with one of the oxygen atom, right? The new OH and H bond is being formed, which is much more stronger. Okay, and thus in the chemical reaction there is just rearrangement of the bonds, right? There would be the breaking and the making of the bonds. Okay, so next is the combination reaction. So before jumping directly into the definition of this term, we'll just see what is happening over here. Okay, this is calcium oxide, okay, which is also known as tuna. So this calcium oxide is going to react with water vigorously and it is going to form a solution of calcium hydroxide, which is written like this. This is the formula for calcium hydroxide, and this is known as quicklime. Okay, quicklime. Now this you should remember, quicklime formula, and this is known as calcium hydroxide. Also it is known as slaked lime. Okay, so what is happening that we are adding CaO plus H2O, okay, and it is leading to the formation of this slaked lime. This is the chemical equation. Quicklime and water are both reacting together, we are treating it, and there is this formation of CaOH whole twice, that is slaked lime. Okay, this is to be remembered, slaked lime and quicklime, also the formulas. Now let me add over here, there is also the evolution of heat in this reaction. If you are going to touch this flask, so what you will observe that suddenly the temperature of this system is going to increase and you are going to feel the hotness in the flask. Okay, so this kind of reaction in which reactants are reacting and product is being formed with the evolution of heat, right? these reactions are also known as exothermic reaction. Like the previous reaction we studied between zinc and acid. Okay, so things to be remembered once again: combination reaction, we have an example in your NCERT that quicklime is reacting with water to form slaked lime. Its formulas, moreover this reaction is also important. So we can now say that those reactions in which two or more elements or compounds, they are combining together to form a single compounds, are known as combination reactions. Okay, so this is the definition. Next, okay, what we just formed, we formed this slaked lime. You remember it? हमने क्या बनाया अभी? ये चूने वाला पानी, right? Slaked lime. So this slaked lime, often you might have seen that in your homes you are going to use this slaked lime for whitewashing. Okay, the solution which a painter is generally using in your homes for whitewash, okay, for, let me write it down, whitewash is this slaked lime. Okay, CaOH whole twice. Okay, now, okay, this solution of slaked lime, what it reacts with carbon dioxide which is present in the atmosphere, and it forms a layer of calcium carbonate on the walls. Now this calcium carbonate which is formed after 2-3 days of whitewashing gives it a shiny finish to the walls. The example of combination reactions, the very first example is photosynthesis. Now I would like you to balance this equation first. Okay, so photosynthesis is also an example of combination reaction. हमने क्या पढ़ा था combination reaction में? That A plus B is going to form AB, right? The same way formation of water is also in combination reaction, right? H2 plus O2 is going to give water. Now next is formation of salt, that is NaCl. Okay, Na plus Cl2, that is 2Na plus Cl2 is going to give you 2NaCl, right? These are some of the examples of your combination reaction. Okay, as we have already read about it, that the reactions in which the heat is released along with the formation of products, okay, products are being formed, also there is the release of heat, or we can say energy. So those reactions are known as exothermic reactions. Okay, some examples of exothermic reaction is the burning of natural gas or methane. When we are burning methane, okay, so it is forming CO2 and water, also it is giving out heat. Okay, so this reactions can be considered under the exothermic reactions, right? So this is the burning of fuel and this is the burning of your petrol or kerosene. Next is an important question again from examination point of view. Respiration is an exothermic process. Yes, respiration is an exothermic process. Why so? Because the food we eat, right, the carbohydrates, that is going to be digested and stored in the form of glucose. When this glucose is reacting with oxygen in the process of digestion, it is going to form CO2 and water, and it is going to release energy, or we can say heat. So as we have studied in our definition, the reaction in which reactants are getting converted into products, also there is the release of energy or heat, that those reactions are known as exothermic reactions. So you just have to explain this and write down. That is the reason we say that respiration is an exothermic process. The same way, decomposition of vegetable matter into compost, that is also an example of exothermic reactions, right? So the things which you need to remember in this is the definition of combination reaction. Fine. Next, the reaction what we studied, CaO plus H2O, its formula, its reaction. Moreover, CaO, what is CaO? Quicklime, right? Just revise with me, quicklime, and it is going to form CaOH whole twice, that is known as slate lime, right? Slate lime. Next, when this CaOH whole twice, it is going to react with CO2, there is this formation of CaCO3, okay, CaCO3 plus H2. Okay, this you should remember. Moreover, what is an exothermic reaction? Also, why respiration is known as exothermic reaction. Fine. So, we are done with the combination reaction. Next example is decomposition reaction. Like the combination reaction, we can say that decomposition, what is happening? Decompose hona, matlab what is going to happen, that A and B are going to form A plus B. जैसे कि हमने लिखा था combination में A plus B is going to form AB, right? The same way, this is the decomposition reaction and this is the combination reaction. Okay. So, here's the definition. A reaction in which a single reactant that is broken down into give two or more simpler products. Simply, that is known as decomposition reaction. Yes, these are opposite of combination. Why so? Because in the combination reaction, reactants were reacting together to give a single product, and in this decomposition reaction, a single reactant is going to break down and it is going to form two or more products. So, it is the opposite of a combination reaction. Next, so in order for these reactions to occur, we need energy in the form of heat, electricity or light. So, in detail we are going to study these three forms, that how the heat is going to help this decomposition reaction, and electricity, also the light, right? When the heat is facilitating the decomposition reaction, it can also be known as thermal decomposition or thermolysis. Lysis means breakdown. The word lysis means breakdown, and when I am writing thermolysis, that with the help of heat we are going to break down a reactant, so that reaction would be either thermolysis you can say, or thermal decomposition. Likewise, with the help of electricity, if this reaction is going to happen, it is known as electrolysis. Finally, when the light is going to facilitate this reaction, it is known as photolysis. Photo means light, again lysis means breakdown. So, the next the example of thermal decomposition reaction. In this, we have this ferrous sulfate crystals. Okay, ferrous sulfate crystals, we have this formula FeSO4, right? So, the actual formula for it is FeSO4.7H2. So, this FeSO4 ferrous sulfate is initially green in color, but when we are going to heat it in a test tube, so it is going to change into this oxide, which is Fe2O3, that is known as ferric oxide, with the evolution of two gases, that is SO2 and SO3, sulfur dioxide and sulfur trioxide, and this SO2 would be giving some rotten smell of sulfur. Okay, right. Crystals, when they are heated, they are going to lose water, okay, and the color of crystal is going to change into this reddish brown color. and with the evolution of two poisonous gases. These gases are poisonous. Yes, and exactly when this reaction is going to happen, FeSO4 is going to convert into ferric oxide, which is left behind in the test tube, and these gases, they escape from the test tube. So this is the first example of decomposition reaction. Here you can generalize it with the definition what we studied, that a single reactant is going to break down into products when heat is supplied into two or more products, right? So this is a example of decomposition reaction. But which decomposition reaction? Thermal decomposition reaction. Next, the thermal decomposition of lead nitrate. Now the decomposition of between when lead nitrate, which is initially white in color, it is heated, it changes into lead oxide, and with the evolution of two gases, the brown fumes of nitrogen dioxide, this gas, which it will be giving brown fumes, it will escape out from the test tube. Okay. Likewise, oxygen will be formed, which also escapes out from the test tube. Again, if you generalize this equation, what is going to happen? What is happening over here? Lead nitrate, a single reactant, when the heat is being provided, it is going to change into lead oxide and nitrogen dioxide. This lead oxide is left in the test tube only, okay, and these two gases escape. So this is also an example of thermal decomposition reaction. Next is thermal decomposition of calcium carbonate. Okay, this reaction, that when we are going to decompose this calcium carbonate, okay, देखिए CaCO3 plus heat, it is going to convert into CaO and CO2. Okay, now you remember that we had this CaO when we were studying combination reaction. This CaO was being treated with water to form CaOH whole twice, and there was the evolution of heat. We were also treating it under the exothermic reactions. CO2, when this CaOH whole reacting with CO2, right, it was forming calcium carbonate and water. Okay, so this is a cycle which you should remember for your exams also. Okay, so again, the thermal decomposition of calcium carbonate, yes, the equation again here is that this CaCO3 calcium carbonate, that is limestone, when it is heated, it is going to give you quicklime and carbon dioxide. Okay, next is the decomposition reaction, but with the help of electricity. So I have written it as electrolysis of water. Okay, lysis means again what I have earlier told you, breakdown and with the help of electricity. This is a setup for electrolysis of water. The whole setup is done to carry out the electrolysis of water. Here you can see that there are electrodes, that they are made up of graphite. Okay, so one is made anode and other is made cathode. On cathode, hydrogen is collected, and on anode, oxygen is collected. So you can remember it, anode is having this O, so on anode oxygen is being produced, and this cathode is having H, so on cathode hydrogen is being produced while carrying out the electrolysis of water. Okay, electrolysis of water. Now, when passing the current, the two gas bubbles are going to collect in this inverted tubes, and one thing here is to note here which is noticeable is that the amount of hydrogen which is being collected is twice more than the oxygen. Now this is also a question which can be asked, that why in the electrolysis of water the amount of hydrogen is twice as that of oxygen. So your answer would be, as the ratio of hydrogen and oxygen in the formation of water is 2:1, so on the breakdown of water we get twice hydrogen as much as oxygen is produced. Okay, so this is the answer for your question. Next is the decomposition reaction while we are using sunlight as the source. In the presence of sunlight, this silver chloride, which is initially white in color, it changes into gray, that is the color of the silver metal, grayish color. Okay, it changes into gray color. Let me write it again. So this initially white silver chloride gets converted into gray color of Ag. This is the chemical reaction. AgCl in the presence of sunlight gonna convert into grayish Ag and chlorine gas. Also AgBr in this form, AgBr reacts in the presence of sunlight. In the presence of sunlight converts into Ag plus Br. Okay, you can balance this reaction, Br2, right? So this will escape. Okay. So this was all about the combination reaction and the decomposition reactions. That's all for today. Thank you and keep studying, guys.